Dr. Miko coming to you Wednesday, February 15th for our lecture. Thursday, February 16th, as you know, I'm going to miss that. So a couple things I asked you guys, if you wanted to couple for your team group project, you may do that, and I would put you on a team. I have assigned the teams. If you go to group project on Blackboard and click on Project Teams 2017, you'll see an Excel workbook with both the 9:30 teams and the 11 o'clock teams. So you team in the 9:30 group worked out, I think there's 25 students. So there's 5 teams of 5, and you'll be with the person you asked to couple with. And the 11 o'clock team group, I think there ended up being 27 students. So I think there's 4 teams of 5 and then 2 teams of 4 or something to that effect, or maybe 3 teams. Yeah, that's 3 teams of 5 and 3 teams of 4. So I gave you guys a name just to be, I don't know, cute or funny. Team Alpha, Team Natural Curve, Team Outlier, Team, that's my favorite one, Team 3 Standard Deviations Above. You may name your team something else. I just wanted to go with a little bit of a stats feel. So that is step 1. We now have a team. On Tuesday, we'll talk about the next step, which is I'll put you together and you're going to try to pick a topic. That's the next thing in our group project. But what I'm going to do today is, you guys were given a handout, which was the quiz that we took last year in the spring of 2016. We're going to take a quiz similar to this in 2017. So I'm going to put that on the doc cam, and we're going to do it together. So that's what I'm going to spend some time doing today. So this is hopefully the handout that you have that I gave you in class. If not, if you can't find that, if you did not come to class for whatever reason, you can find that handout as well on Blackboard under Chapter 10, Hypothesis Testing, and it's the very top. I told the 11 o'clock class this, but not the 9:30 class this. I'm going to ask you guys to hand this in on Tuesday. That's Tuesday, whatever that day is next week, for a grade. I'll get it out of 5. So I'm going to do it for you. So basically, if you follow through with me, you should get a 5 out of 5 on that. So that's going to be due Tuesday as well. We're going to have an in-class quiz very similar to this on Tuesday, and then we're going to go a little bit further with hypothesis testing. So let's go back to this assignment. So I'm going to try to structure this as much as I can for you, and you'll see there's A through J is the steps involved in this process. So it says, Dr. Miko believes that the average number of minutes that middle-aged adults spend working out is less than 100 minutes per week, and he knows that the standard deviation of minutes working out per week is 20. To test this claim, he samples 16 adults and finds a sample mean of 90 minutes. Test this claim at the 5% significance level. Okay, so let's do a couple things. It says state the null and alternative hypothesis. So that's part 1. Well, it looks like Dr. Miko is claiming that it's less than 100 minutes per week. So we're going to go with, we're trying to prove the mean is less than 100. So that means automatically that the null, the mean, is equal to 100. Okay, that is step A, or step 1. Done. Okay. B says draw the graph. Now, we say draw the graph, we actually end up drawing 2 graphs, but because this is less than, we know the evidence is on the left-hand side, so this is a left tail test. So I'm going to draw the first graph in terms of x bar, and the second graph in terms of z. Okay. Couple of things that were given up the top. Let's go back there. It says standard deviation, it tells me, is 20. It told me I sampled 16 adults, and it told me the significance level is 5%. So let me zoom out a little bit here. So that means this is a left tail test with alpha is equal to 5% here. Alpha is equal to 5% here. Okay? And the standard deviation of this is 1, right? Standard normal curve, standard deviation is 1. So if you think about it, that's part B. I drew the graph. I realized that it was a left tail test. I drew the curve as far as x bar, the curve of z. Now it says, set up the rejection region in terms of x bar and z. We have to start with z. So I know, because I have a little table that tells me that, if alpha is 5%, that means the z value is 1.645. Well, in this case, because it's a left tail test, this is negative 1.645. So that's a rejection region in terms of z. I want to get it in terms of x bar. What's the rejection region in terms of x bar? I need to convert this z value to an x bar value. If you recall, the formula that does that looks like this. X bar is equal to mean plus z times the standard deviation divided by the square root of n. So let's get out our little calculator and we'll go from there. So let's see. X bar, and it's the upper bound of the rejection region because it's the top end of the rejection region, is the mean is 100 plus negative 1.645. That's my z value. The standard deviation, it tells me, is 20. N is 16. So that's going to be square root of 16 is 4. 20 divided by 4 is 5. So let's see. 5 times 1.645. That's a negative, so I'm going to make that negative. Add 100. What did I screw up there? So 5 times 1.645, make that negative, plus 100. I did 1,000, that's what I did, so minus 1,000 plus 100. So 91.775. Okay, so 91.775 is the upper bound of my rejection region. So at this point, I have both C, I have A, B, and C done. C, I have the rejection region in terms of both Z and X bar. Okay, I have the rejection region in terms of both Z and X bar. D says, hey, compare your test statistic to the rejection region. Well, when I sampled those 60 adults, I got an X bar, a sample mean, it says, of 90 minutes. That's my evidence. That's my test statistic. X bar, my test statistic is 90 minutes. Let's see where 90 fits. Well, 90 is in the rejection region, okay? It is in the rejection region, so it says compare your test statistic to the rejection region. I did. That's kind of just, verbally doing that. It says, E, what is your conclusion? Well, since it's in the rejection region, I'm going to zoom out here a little bit. Since it's in the rejection region, my conclusion, E, would be decision 1, reject the null in favor of the alternative. Now let's think about what I'm saying. I'm saying there's enough evidence to support this claim, that the mean is truly less than 100. Okay, that is through E. F says calculate the p-value. All right, so let's remember what the p-value is. The p-value is what is the probability of observing a value at least as extreme as the test statistic computed. The test statistic computed was 90, okay? X bar was 90. We know that it was less than 5% because it was in that rejection region, but we don't know exactly how far it was in. So F, what we're looking for our p-value, is the probability that X bar is less than 90. Okay, that's our test statistic. What's the probability that it's less than 90? Well, that isn't something I can calculate on my own. I need to convert that x bar to a z-value. The probability that z is less than, let's see, 90, which is our x bar value, minus our mean, which is 100, divided by my standard deviation, which is 20, divided by the square root of n, which is 16, gives me the probability z is less than negative 10 divided by 5. The probability z is less than negative 2.0. So in the world of z, x bar equal 90 is equal to z of 2.0. It's also in the rejection region, right? It makes sense, right? Because it's the same thing. The 90 is to the 2 as the 91.775 is to the negative 1.645. These two things are rejection regions. These two things are test statistics. One is in terms of z, one is in terms of x bar. The probability, the p-value, is the probability of observing a value at least as extreme as the one computed. Extreme in this case is less than. The probability z is less than negative 2 is my p-value. So let's look for that. I need to get out my z table. I need to turn to the negative side. The negative side, negative 2.0, says 0.0228. That is my p-value. 0.0228. That is my p-value. The probability of observing a value at least as extreme as the test statistic computed. Okay, very good. Now it says, let's see, part G says, in a word, how much evidence do you support the alternative hypothesis? So remember, we had a little table, okay, and I'm not going to give you this table, you kind of have to memorize it. If the p-value is less than 0.01, we said there was overwhelming evidence. If it was between 0.01 and 0.05, we say there is strong evidence. And if it's between 0.05 and 0.10, we say there's weak evidence. And if it's greater than 10%, we say we have no evidence. Well, 0.0228 is between 1 and 5%. So in this case, we have strong evidence. And you could have just written strong. I just wanted to show you where that came from. So I'm through G. Okay, G says, in a word, how much evidence do you have? I have strong evidence. Does the p-value confirm the conclusion in part E? It does. Why? Because the p-value, which is 0.0228, okay, the p-value, which is 0.0028, is less than the significance level, which is 0.05, which means it's in there, which means the test statistic's in there. Anytime the p-value is less than the significance level, I make decision 1 to reject. So the answer to this one is yes. And it's always going to be yes, because the p-value just confirms what we already learned. Now how about I and J? I says, you know, what if it was at the 10% significance level? Would our conclusion still be the same? Let's think about it. If it's 10%, I'm saying I need weak evidence or better. Well, hell, I have strong evidence. Would my conclusion still be the same? Sure, I still have enough evidence, because 0.0228 is still less than 10%, so we'd still make decision 1 and reject. J, if you look back to the problem, J says, how about at the 1% significance level? Well, at the 1% significance level, if you think about it, I'm saying I need overwhelming evidence. Do I have overwhelming evidence? No, I have strong evidence. Well, because 0.0228, my p-value, is greater than 1%, I make decision 2 and do not reject. So, you know, just to zoom the whole way out of this damn thing, okay, just to get, I can't zoom any further out. But what we're saying here, if you think about it, the p-value tells me exactly how much evidence that I have. and that one p-value tells me I have strong evidence. The rejection region is 5%. Hey, I'm good. It's strong evidence. I need strong evidence. 10%. Hey, I'm still good. I only need weak evidence. I have strong evidence. Even better. But if it's 1% where I need overwhelming evidence, but I only have strong evidence, just not quite enough. Okay? So that is where we're at with problem 1. Now, you'll hand this in, so hopefully you were able to follow along with what I did, and if not, pause the video, listen to it over and over again until you understand. You're going to hand this in on Tuesday, and I'm going to give you a 5 out of 5, if it's right. Hopefully it's right. On Tuesday as well, you're going to take a quiz very similar to this one. Now, if we go to Blackboard, you may be saying, well, Dr. Miko, I still don't feel really prepared. Well, if we go to Blackboard, I want to show you I have some sample questions out there. This is under Chapter 10, Hypothesis Testing. There's something that says Dr. Miko Hypothesis Problems. If we look at that, that's a Word document of Dr. Miko problems that I've made up. They're very similar to that one. And I'm going to give you one of these. So there's 3 here, okay? All very similar. I'm not going to solve those. I'd like you to do that for homework, and I'm not going to check that. But go ahead and do it for homework. And one of whatever quiz I give you on Tuesday is going to be one of these 3 problems. So if you do them ahead of time and understand them, you should be able to get 100% on that quiz. Same way, it walks you through, let me zoom out of this, it walks you through, like state the hypotheses, draw the graph, set up the rejection region, all those good things. Okay, so since the homework was a left tail, I'll probably end up giving you a right tail test for the quiz. Now, additionally, one other thing that I want to go over today. Everything we've done so far in hypothesis testing has been manual. Okay, it's been us doing it by hand, and to understand the concepts, it kind of makes sense to do it manually. We can kind of get a sense of, all right, this is what I'm saying. It's far enough to the left or it's far enough to the right, and it is a more difficult concept. But if we want to use Excel, and I'm going to show you how to use Excel today, it kind of can do all the math for us. So under Chapter 10, Hypothesis Testing, there is a workbook that says teststatistics.xls. So if we click on that, remember the estimator workbook we used in the last section? This is very similar to that in that there's multiple tabs here. We want to go to z-test mean because that's what we're working with right now. Excuse me, I'm still sick. So, and it works kind of the same way. If you look, everything in column B, we're doing a z-test of a mean because we're testing a mean using the z-curve. Everything in column B is input, everything in column D is output. So if we were to do the problem that we just did, in Excel, instead of doing the math, here's what we do. Okay, so let's go back to that problem. We're looking for that it's less than 100. We did a sample mean, a test statistic of 90. It told us the standard deviation. Oops, you guys can't see this. It says Dr. Miko believes that the average number, so we're looking for less than 100. That's my hypothesized mean. It says the standard deviation it gives me is 20. It says my sample size is 16. And my test statistic, my sample mean was 90 minutes. And we're testing this claim at the 5% significance level. So all these values are here. The sample mean, which is my test statistic, is 90. My standard deviation was given as 20. Remember, I sampled 16 things. I'm trying to prove the mean is less than 100, so I'm going to put in 100 there. And my alpha is 0.05. Now it returns a couple things. A couple things that you saw when you did the problem manually. The z statistic is negative 2.00. Remember, that's what we did when we converted that 90 to a z value, right? There it is again. And really, there's only one thing, and there's the rejection region. You see that 1.645? Don't worry about this two-tail stuff. We'll talk about that later. But only really one value you need to worry about, be concerned with, is that p-value. The p-value is 0.0228. In a word, that is what? Strong evidence. So you can do, what I'd suggest you do, is remember I told you that this workbook in Excel contains 3 problems, one of them which will be tested on. So if I want to do it myself, but I want to test my answers, use the test statistics workbook to test it. Let's look at this first one. We'll do this first one with Excel. The admissions officer for the grad programs at SFU believes that the average score in the GRE exam is significantly higher than a national average of 1,300. Assume that the population standard deviation is 125 and a random sample of 25 scores had an average of 13.5. Assume a significance level of 5%. I'm just going to copy this over to that workbook so I have it in one place. Let's just copy it down here. And I'm just going to merge that text. I can read this. Okay. So what does my sample mean? Well, it looks like I did a sample 25 and got 1375. So 1375 goes here. The standard deviation is 125. The sample size I took was 25. And I'm trying to see if it's greater than 1,300. So that's my hypothesized mean. Doing all that, all I really need to be concerned with is a p-value of 0.0013, which in a word means I have overwhelming evidence. That would be enough at the 10% significance level, it would be enough at the 5% significance level, and it wanted to be enough at the 1% significance level. So that's all I'm going to do. I just wanted to show you that. So Tuesday, we're going to have that little quiz. You're going to hand in this little assignment that I did. We'll have some time at the end to get together in our groups for the first time. And we're also going to go into hypothesis testings of the proportion. So I hope you have a great weekend. I'm sure you're hoping that I feel better and my voice changes and goes back to normal. I'll see you on Tuesday. Take care. Goodbye.